AFCIs, or arc fault circuit interrupters, can indeed function properly on multi-wire circuits. The National Electrical Code, known as the NEC, does not mandate that you feed your work with a new circuit directly from the panel, even when the existing circuits are multi-wire configurations. However, it's essential to provide AFCI protection for all new branch circuits and any alterations made to existing branch circuits. While not strictly an NEC requirement, it is considered best practice to feed your work with a new circuit from the panel. This approach helps ensure proper AFCI protection and minimizes the risk of electrical hazards. This is particularly relevant if the existing multi-wire circuits are older or have a history of issues. If you opt to utilize an existing multi-wire circuit, there are specific steps to follow. Firstly, install an AFCI breaker in the panel to protect the new circuit. Secondly, ensure that the hot and neutral wires are properly identified throughout the circuit. Thirdly, connect the hot and neutral wires to the AFCI circuit breaker using a pigtail. Fourthly, install a ground fault circuit interrupter outlet (AFCI) as the first outlet on the new circuit. This provides added protection against ground faults. It's important to note that this method will only provide AFCI protection for the new branch circuit and not the existing outlets on the multi-wire circuit. Now, let's delve deeper into AFCIs and their operation. An AFCI is a circuit breaker that breaks the circuit when it detects an electrical arc. Arcs can occur when damaged or deteriorated wires, loose connections, or faulty appliances create an unintended path for electrical current. These arcs can generate heat and potentially ignite surrounding materials, leading to fires. There are different types of AFCIs, including branch/feeder AFCIs and outlet branch circuit AFCIs. Branch/feeder AFCIs are installed in the electrical panel and protect the entire branch circuit, while outlet branch circuit AFCIs are installed at the first outlet on the circuit and provide protection for the wiring downstream from that point. Multi-wire branch circuits, sometimes called shared neutral circuits, share a common neutral conductor between two or more hot conductors. These circuits are used to save on wiring costs and reduce voltage drop, but they require careful wiring and protection to ensure safety. When installing an AFCI on a multi-wire circuit, it's crucial to ensure that the AFCI is designed for use with multi-wire circuits. Some AFCIs are specifically designed for this application and can detect arcs on either of the hot conductors. It's also important to properly identify the hot and neutral conductors to ensure that the AFCI is wired correctly. Incorrect wiring can cause the AFCI to malfunction or not provide adequate protection. The NEC provides specific requirements for AFCI protection in various locations throughout a home. For example, the NEC typically requires AFCI protection for branch circuit supplying outlets in bedrooms, family rooms, living rooms, dining rooms, and other similar areas. These requirements are intended to reduce the risk of electrical fires in areas where people are most likely to be present. When working with electrical systems, it's always important to follow safe work practices. This includes turning off the power to the circuit before working on it, using insulated tools, and wearing appropriate personal protective equipment. If you are not comfortable working with electrical systems, it's best to hire a qualified electrician to do the work. To further clarify some points, let's consider a hypothetical scenario. Suppose you are adding a new bedroom to an existing home and the existing second floor is fed by multi-wire circuits. You decide to tap into two different existing circuits for ease and diversity. In this situation, the NEC requires you to provide AFCI protection for the new branch circuit you are installing. You can do this by installing an AFCI circuit breaker in the panel that protects the new circuit. Alternatively, you could install an outlet branch circuit AFCI at the first outlet on the new circuit. However, if you choose to use an existing multi-wire circuit, it's crucial to follow the steps outlined earlier. Firstly, install an AFCI breaker specifically designed for multi-wire circuits in the panel. Secondly, carefully identify the hot and neutral wires to ensure proper wiring. Thirdly, use a pigtail to connect the hot and neutral wires to the AFCI circuit breaker. Fourthly, install a AFCI outlet as the first outlet on the new circuit for added protection against ground faults. Remember that this method only provides AFCI protection for the new branch circuit and not the existing outlets and the multi-wire circuit. If you want to provide AFCI protection for the existing outlets as well, you would need to replace the existing circuit breakers with AFCI circuit breakers. It's also worth noting that some jurisdictions may have additional requirements for AFCI protection beyond what is specified in the NEC. It's always a good idea to check with your local building department to ensure that you are complying with all applicable codes and regulations. Furthermore, when dealing with older electrical systems, it's important to be aware of potential hazards such as deteriorated wiring, loose connections, and outdated components. These hazards can increase the risk of electrical fires and other electrical problems. If you are unsure about the condition of your electrical system, it's best to have it inspected by a qualified electrician. An electrician can identify any potential hazards and recommend appropriate repairs or upgrades. In addition to AFCIs, ground fault circuit interrupters, GFCIs, are another important safety device that helps protect against electrical shock. GFCIs detect ground faults, which occur when electrical current leaks out of its intended path and flows to ground. Ground faults can be caused by damaged or deteriorated wiring, faulty appliances, or wet conditions. When a GFCI detects a ground fault, it quickly shuts off the power to the circuit, preventing electrical shock. The NEC requires GFCI protection in various locations throughout a home, including bathrooms, kitchens, garages, and outdoor areas. When installing a GFCI, it's important to follow the manufacturer's instructions carefully. Incorrect wiring can cause the GFCI to malfunction or not provide adequate protection. It's also important to test the GFCI regularly to ensure that it is working properly. To test a GFCI, simply press the test button on the device. The GFCI should trip and shut off the power to the circuit. If the GFCI does not trip, it may be faulty and need to be replaced. In summary, AFCIs and GFCIs are essential safety devices that help protect against electrical fires and electrical shock. When working with electrical systems, it's important to understand the requirements for AFCI and GFCI protection and to follow safe work practices. If you are not comfortable working with electrical systems, it's best to hire a qualified electrician to do the work. Let's also consider some common misconceptions about AFCIs. One misconception is that AFCIs are a replacement for GFCIs. However, AFCIs and GFCIs serve different purposes and provide different types of protection. AFCIs protect against electrical fires caused by arcs, while GFCIs protect against electrical shock caused by ground faults. Both AFCIs and GFCIs are important safety devices and should be used in conjunction with each other to provide comprehensive electrical safety. Another misconception is that AFCIs are only required in new construction. While the NEC requires AFCI protection for new branch circuits and alterations to existing branch circuits, it's also a good idea to install AFCIs in older homes to improve electrical safety. Older homes may have deteriorated wiring and other electrical hazards that can increase the risk of electrical fires. Installing AFCIs can help protect against these hazards and make the home safer. A further misconception is that AFCIs are expensive and difficult to install. While AFCIs may cost slightly more than traditional circuit breakers, they are a relatively inexpensive safety device compared to the potential cost of an electrical fire. AFCIs are also relatively easy to install and can be installed by a qualified electrician in a short amount of time. Now, let's discuss some troubleshooting tips for AFCIs. If an AFCI trips frequently, it may indicate a problem with the electrical circuit. Some common causes of AFCI tripping include faulty appliances, loose connections, and damaged wiring. To troubleshoot an AFCI tripping problem, firstly, try unplugging all appliances on the circuit to see if that resolves the issue. If the AFCI stops tripping after unplugging the appliances, then one of the appliances may be faulty. Secondly, check all connections in the circuit to make sure they're tight and secure. Loose connections can cause arcs, which can trip the AFCI. Thirdly, inspect the wiring on the circuit for any signs of damage. Damaged wiring can also cause arcs, which can trip the AFCI. If you are unable to resolve the AFCI tripping problem yourself, it's best to hire a qualified electrician to diagnose and repair the issue. In addition to the above information, it's also important to be aware of the different types of AFCI circuit breakers available. There are combination type AFCI circuit breakers, which provide both arc fault and overcurrent protection, and there are dual function AFCI/GFCI circuit breakers, which provide arc fault, ground fault, and overcurrent protection. The type of AFCI circuit breaker you need will depend on the specific application and the requirements of the NEC and your local electrical codes. Also, remember that electrical codes and regulations can vary depending on your location. It's essential to consult with your local building department or a qualified electrician to ensure that you are complying with all applicable codes and regulations. Ignoring electrical codes can lead to safety hazards and potential legal issues. Electrical safety is a critical aspect of home ownership and should never be taken lightly. By understanding the requirements for AFCI and GFCI protection, following safe work practices, and hiring qualified professionals when needed, you can help ensure the safety of yourself, your family, and your property. Moreover, consider the long-term benefits of investing in electrical safety upgrades. While there may be an upfront cost associated with installing AFCIs, GFCIs, and other safety devices, these investments can save you money in the long run by preventing electrical fires, reducing the risk of electrical shock, and improving the overall safety and efficiency of your electrical system. In addition, a safe and well-maintained electrical system can increase the value of your home. Potential buyers will appreciate the peace of mind that comes with knowing that the electrical system is up to code and in good working order. To summarize, when dealing with multi-wire circuits and AFCI protection, keep these key points in mind. AFCIs can function properly on multi-wire circuits, but it's crucial to use AFCIs that are specifically designed for this application. The NEC requires AFCI protection for new branch circuits and alterations to existing branch circuits. While not required by the NEC, it's best practice to feed your work with a new circuit from the panel to ensure proper AFCI protection and reduce the risk of electrical hazards. If you choose to use an existing multi-wire circuit, follow the steps outlined earlier, including installing an AFCI breaker, identifying the hot and neutral wires, using a pigtail, and installing a GFCI outlet. Remember that this method only provides AFCI protection for the new branch circuit and not the existing outlets in the multi-wire circuit. If you want to provide AFCI protection for the existing outlets as well, you would need to replace the existing circuit breakers with AFCI circuit breakers. Always consult with a qualified electrician if you have any questions or concerns about electrical safety. They can provide expert advice and ensure that your electrical system is safe and up to code. By following these guidelines, you can ensure that your electrical system is safe and reliable and that you are protecting yourself and your family from electrical hazards. And finally, make sure you always keep up with electrical safety information. Electrical codes and technologies are always being updated, so you always need to stay current with these codes. This will help prevent any accidents.